Hi, my name is Abigail Batten. I'm in Heat and Mass Transfer with Professor Jimmy Lawrence, and today I'll be presenting cooking French toast in a clamshell griddle using COMSOL Multiphysics. The goal of this assignment was to be able to demonstrate the use of either heat or mass transfer in COMSOL Multiphysics by applying it to a real-world problem. For me, I cook French toast for breakfast a lot in the mornings using a griddle that is similar to the one shown on the left. So for this assignment, I created a model of the griddle in which the bread is being cooked in between the two layers with heat being applied to both surfaces. So within COMSOL, I used the time-dependent feature so that way I could tell how my temperature was changing across time. I wanted to ensure that my center temperature of my piece of bread was approximately 130 degrees Fahrenheit, so that way it would be hot enough to be crispy on the outside, but so that it would not burn someone's mouth, as you can burn someone at about 140 degrees Fahrenheit. I also wanted to ensure that my egg surface was cooked correctly to a temperature that was safe at approximately 160 degrees Fahrenheit. So for my parameters, I set up my bread thickness at approximately 0.4 inches. My grill temperature was equal to 350 degrees Fahrenheit, which is also equal to 449 degrees Kelvin. And for my thickness of my bread, I used 0.05 inches on both the top and the bottom. After setting up the constants within my program, I wanted to start building a 2D model for my French toast. So notice on the left side I have 4 rectangles listed. For rectangle 1, this was the layer that represented the first layer of the egg on the side of my French toast. The width of it was the width of the egg, and the height was the same as the full length of the bread, and the position at which it started was at the origin. My second piece was rectangle 2, which represented half of the entire length of the bread. The reason I chose to do 2 separate pieces for the bread is so that I would be able to determine the temperature at the center. So for rectangle 2, the width is half of the entire length of the bread, and the height is the entire length of the bread. For my position along the model, it started at the edge of the egg. And I also have rectangle 3 and rectangle 4, which are pretty much the exact same as these two, just the other half of the side of the toast located in the appendix. So this is what the actual 2D model of the entire piece of French toast looks like within COMSOL Multiphysics. One assumption that I did have to make is that I could not model the layer in which the egg and bread was mixing. So I did have to make the egg a separate layer and the bread separate. So the first block, which is this one between these two lines, is the first layer of egg, and the following layer is the half of toast. And the other side is just the exact same thing. So after creating my 2D model, I had to define my materials, which is shown on the left. They are labeled as egg and bread. For the material labeled egg, I defined the domains as the rectangle on the furthest to the left and the furthest to the right, and I defined the properties at the bottom based on the ones that I had specified within parameters for egg. For the second material, I had bread. I also defined the domains as the 2 rectangles in the middle, and its properties were defined previously from the parameters slide. So in order to calculate the heat transfer in my solid, I had to define a few different other parameters. I had to show the thickness of the entire model, which is shown on the bottom. And with this, it calculated the change in the heat transfer throughout the entirety of the 2D model that I created. I also set the original temperature to room temperature. This is also equal to 68 degrees Fahrenheit, and the pressure to 1 atmosphere. And then in order to pull my values, I pulled them from the materials, and the material section pulled it from the parameter section. The equation that's actually used to calculate the heat transfer is also shown within COMSOL. It does it automatically, and I included it in Appendix D. After setting up my heat transfer, I wanted to set the boundaries for the grill, which is shown by temperature 1 and temperature 2. So for temperature 1, I used the previously defined value, which was that the top temperature of the grill surface was approximately 449 degrees Kelvin or 350 degrees Fahrenheit. So that's actually shown by the picture shown in the top right. This blue line represents the egg layer coming into contact with the top layer of the grill. And the same thing was done for temperature 2, which is shown by the picture on the bottom right. The blue line represents the egg layer connecting with the bottom side of the grill. Underneath heat transfer, I also set up an insulation layer on my model, which is shown by the picture in the bottom right. So the blue lines on the top and bottom represent a thermal insulation layer, and what this ensured was that the model was 2D and there was no heat transfer occurring across those boundary lines. So my next step was to set up some initial values. You'll notice from earlier I did mention that I set the model up so that the temperature at all parts of the system was originally at room temperature. And then in the top right, I have a time-dependent solver set up such that for the range from 0 to 800 seconds, it calculated the change in temperature. I also set up a few variables that I wanted to be measured. So first I had to set up the mesh, which is shown by the bottom right picture, and that just shows how finely the change in temperature across your model is measured. I had to set up line averages, which is shown on the left. So what these basically did was it took the average temperature across each measured value in the change in time. So for the line average of 1, it was the surface between the top of the grill and the first egg layer. I also did this for the second line, which is between the egg and the bread, the center temperature of the bread, and I also did it for lines 4, which is between the egg and bread layer, and then for line 5, which is the bottom surface of the grill and the egg. So after running my model, I found that the average line temperature, which is shown by table 2, the table in the middle, that the temperature at which my egg reached 160 degrees Fahrenheit in order to be fully cooked was between 2 and 3 seconds. And my table 3, which is shown on the far right, shows the value of the center temperature of the bread. So at just about 27 seconds is when it went above the 130 degree mark in order to not burn someone's mouth, but also to be hot enough. So the picture that's shown in the middle is actually from when I ran the experiment in real life. As you'll notice from the temperature probe, the center temperature of the bread is approximately close to 130, and this is when the grill is run at 350, which is equal to the 449 Kelvin that was set up originally. And you can see that the time was approximately 28 seconds. So what this shows is that the model in COMSOL was able to accurately approximate the real life value. So just to reiterate the results, I wanted to ensure that the egg was cooked to at least 160 degrees Fahrenheit, which took 3 seconds, and in order to reach the center temperature of 130, the bread needed to be cooked to 27 seconds. So overall, I would cook the French toast to 27 seconds. And in the appendix, I've also included a 2D model of the heat transfer at the time of 27 seconds. This appendix just shows the additional details for the last 2 rectangles within the 2D model. Appendix B is all of the links for my constant values at the beginning that I put inside of COMSOL, as well as the value of what temperature I need to cook eggs to in order for it to be safe, and at what temperature humans can burn their tongue at. Appendix C just shows the heat transfer across the entire model at 27 seconds. Appendix D shows the equation that is used by COMSOL in order to calculate the heat transfer.